Dear friends, welcome to the lecture on phase diagram of iron carbon system. Today in this class we will discuss phase like ferrite, austenite and cementite, martensite, ladurite. How temperature and carbon contents influence the microstructure of steel. So friends, as we know that iron is one of the most and very important element and its alloys are mostly used. So they are one of the most widely used material for engineering application. So this is the iron carbon diagram. So first of all we will discuss about its main phases, then once come back and discuss about it. There are major uses of alloy phase diagram. So we will discuss why we are used or study the carbon iron diagram. Development of new alloy based on the application requirement. So after knowing this, we have knowledge, we can develop the new alloy as per our requirement. Production of these alloy and development and control of properties appropriate for the heat treatment procedure such as tempering, annealing, normalizing, etc. to improve the chemical, physical and mechanical properties of these new alloy. Definition of the structure. Various phases that appear on the iron carbon equilibrium diagrams are austenite, cementite, ferrite, martensite, ladurite. So definition of the structure we are first discuss about the ferrite. Ferrite is known as alpha solid solution. It is interstitial solid solution of a small amount of carbon dissolved in alpha BCC iron, stable form of iron below 912 degrees Celsius. The maximum solubility of carbon is 0.022% at 727 degrees Celsius and it dissolves only 0.008% carbon at room temperature. It is the softest structure that appear on the diagram. So ferrite is the softest structure that appear on the diagram. Ferrite is magnetic below 768 degree Celsius. Has a density of 7.88 gram per centimeter. The limited solubility is expressed by the shape and size of BCC interstitial position. This is the microstructure of the ferrite. Austenite is an interstitial solid solution of carbon dissolved in FCC iron. Maximum solubility of carbon is 2% at 1130 degrees Celsius. While in the case of ferrite, solubility of carbon up to 27 degrees Celsius, 0.022%, and at room temperature it will go up to 0.008%. It is normally not stable to room temperature, but under certain conditions it is possible to obtain austenite at room temperature, about which we will discuss in the next lesson. Austenite is non-magnetic. Ferrite is magnetic while austenite is non-magnetic. Very important in the heat treatment of the steel. This is the structure of austenite. Ferrite. Delta ferrite. Delta ferrite is the same as the ferrite. It is stable at a relatively high temperature. Cementite is formed when the solubility limit is exceeded. It is very hard brittle intermetallic compound of iron carbon as Fe3C. Contain 6.67% carbon. It is the hardest structure that appear on the iron carbon diagram. Exact melting point is unknown. It is critical. Its crystal structure is orthorhombic. It is only metastable. It is very low decomposition. Perlite. Perlite is the eutectide mixture of containing 0.8% carbon and is formed at 723 degrees Celsius on very slow cooling. It is very fine plate-like lamellar mixture of ferrite and cementite. The white ferrite matrix contain thin plate of dark cementite. Perlite has properties intermediate between the soft ductile ferrite and the hard brittle cementite. This is the structure of the perlite. Ladoberite, it is eutectic mixture of austenite and cementite. It contains 4.3% carbon and is formed at 11.30 degrees Celsius. Martensite is supersaturated solid solution of carbon ferrite. It is formed when steel is cooled so rapidly that change from austenite to perlite is suppressed. The interstitial carbon atoms of discharge the BCC ferrite into the BCC tetragonal structure responsible for the hardness of the quenched steel. So friends, we are seeing what are the main phases get in the iron carbon diagram. So once we look over it, just like alpha phase in ferrite and cementite, and look here the 727 degrees Celsius below which austenite decomposes into ferrite plus cementite, which is properly known as perlite. And here we are seeing that alpha phase yani austenite, and here austenite plus cementite in this region. So we will discuss more deeply about other points about the iron carbon diagram. So request, if you are not subscribe this channel right now, please subscribe it and share it to your friends. And you think something needed to improve, please write down in the comments. So we'll meet in the next important lecture. Thank you.